Okay guys, so welcome back. Now, first of all, do we have Rahul on the call? So Rahul, if you are there, is your issue resolved? Like you were not able to watch the videos yesterday. I think Rahul is not yet on the call. No problem. Now let us start with the assignment. Did anybody get chance to try on this assignment? Anyone? We had this assignment yesterday. Anyone got any chance to check on this? I think nobody. No problem, guys. You can take your time. I think this week, before we meet in our next session, maybe you can try and find out answers to these questions. Okay, so let us start with today's session. And today we are looking at two new activities where we'll be discussing about how to set up replication when the table structure is different. Now, this is a typical situation and you might encounter this one. See, every time it doesn't mean that you will have same definition tables, right? The column names might be different or column order might be different, or the number of columns that you are trying to replicate in the source are less than the target columns. It might happen. So you need to have a mechanism where you can map single column. For example, we have table 1, okay, and this is table X, right? This is on the target. Now table 1 is having column names like 1, 2, 3, 4, and I want to replicate all these 4 columns, and on the table X I have A, B, C, D, E, F, G, H, and a few more columns. Now I want that 1 to be mapped onto A, and 2 should be mapped onto C, and then 3 should be mapped to D, and 4 should be mapped onto F. Something like that. A typical example which I have given you. This might happen in real time where you have to map source columns to different name of the column in the target, and also the order might be different. It doesn't mean that 1 2 3 4 is going like this, right? This is the order of the columns. In this target table the order might change, or it can be in any order. Possibly I can map 1 to G, and 2 I can map onto maybe B, and then 3 I can map onto D. Any order. This might be the client requirement. Okay, might happen. So this kind of mapping is something we are going to learn in today's session. Earlier what we have learned is, if you remember, the two key parameters I would like to talk. One was pass through. Pass-through will be used in data pump, but as we know that it's a default parameter, right? By default, it will be enabled. That means we are passing the data without any transformation. So definitely, even in this case, when we look at this replication, we don't have any transformation. See, transformation is different. For example, I want to transform the date format. When I'm getting the data from the source, I want to change the date format. That is called as transformation. So remember, transformation is different from mapping. Transformation of data is different from mapping of columns. So this is what we are going to see. We are going to see how to map columns from source to target one-to-one. And also we have two cases. Okay, it might happen that I have a table Y. Okay, and in table Y I have columns something like this, like A, B, 1, 2, 3, and 4. This might happen. So I want to map these columns from the source table. So in this case, we call it as semi-different table. Okay, this is a term which is given by me. You won't find it anywhere. So semi-different means the structure of the columns or the column names are half different. and half are similar, or maybe some are same and some are different. Now we are going to see this replication where the table structure is completely different and where your table structure is semi-different. So these are the two things we are going to see. Earlier in the, what do you call, replicate parameter file, we have used the parameter assume target def, right? Assume target definitions. What is this parameter? This parameter actually tells Golden Gate that the table structure is same, the column names are same, and Golden Gate, really, it does not really need to do any checks on the column names. Directly, it can read the data from source and push the data onto the target table, right? But now we have a different scenario, so we won't be using this parameter anymore because the table definitions are different. And yeah, some in the first case that we'll be looking at, we'll have a completely different table. The second case that we'll be looking at will have a semi different table. Okay, so these are the two things we are going to see right now. And before I get on to the activity, one thing I want to tell you over here, there's a new concept and you're going to learn something about definitions file. Okay, this is known as Golden Gate definition file. So what is this definition file? When your source and target tables have a different structure, okay, see, assume target definitions, that means see, definition over here in terms of Golden Gate, definition means the structure of the table. Okay, don't get confused. Even earlier I used to think like, what is this definition? Is it something that it will define? See, when you look at Golden Gate product, you have to look it as a multi-vendor product. Now in Oracle, we call it as structure, table structure. But globally, when we talk about different databases, we need to give a normal or a general name. So that's why when we work with different database vendors, we call it as table definition. Okay. So in this case, what we are going to do is we are going to generate a definition file of the source table. So as per the earlier as per the earlier example, I have table 1. What I will do is,
I have a question.
Yeah, please tell me.
I can understand the mapping of the columns, but what does the transformation mean?
Yeah, so one example I gave you in the transformation, let's take the source date format is in different, like just a simple example I'm giving because we have a separate session on it. Let's take my source date format is DD, MM, YY, YY. And on the target, I wanted something like MM, then DD, and then YY. Okay, so this is a data transformation example. I am transforming the data. Okay, so transformation means I'm making some changes to the data. So that's one example. Also in the when you want to club to,
We can append data on it or not?
yes. One more example. Let's take in source you have first name, last name. On the target you want to club both of them and push it over there, like first name and last name. You want to join them. You want to add some initials. So there are a lot of things you can do in data transformation. Yes. I hope that helps you.
Yep.
Okay. Don't worry. We have a separate session on data transformation because we'll be working on it. Now let's get back to the definition file. Now in the source, I have a table. So what I need to do is, because the table structure is different in the source and the target. Okay, so table. Now one more thing, guys, table names might be same. So that just to increase a little bit of complexity, I have used the same table name, but the structure is different. Might happen. So in the source, how many columns we have? 1, 2, 3, 4, 5. We have 5 columns. On the target, maybe I have more than 5 columns. right? So let's assume we have 10 columns over here. So while you use the replicat, okay, we need to direct replicat to read a file, and this file will contain the source definition. Okay, so it will have the details or the structure of the source table. Now the replication process that we have will have an added file. So how does the new replication process work? First of all, what we need to do is we need to generate. Okay, I'll write it over here. So we need to generate the source definition file. Okay, that's the first thing. Second, third, fourth, fifth are normal steps. Nothing but you configure the extract, then you configure the data pump. Next would be your replicat, and in replicat you will actually refer to the source definition file, because before replicat can push the data into the target columns, it will read the source definition file to understand what is the structure of the source table. So what is the new learning that we have right now is in Golden Gate we can actually define, or we can actually create the definition file of a source table when the structures are different. And also remember, this will be used when your databases are different. So when we are working on our project with the multi-vendor, we have two projects, right? So in those projects you will understand the more importance of the definitions file. For now, we have very simple activity in Oracle vendor. When your source is Oracle, target is Oracle, how do we use the definition file to perform the replication? So let us start with the activity. Right guys, so this is the replication activity that we have. Now in this one, we have the same Fox schema. We have the Tom schema on the target, right? And the table name that I'm using is tab 3. On the target, I have changed the table name, tab 3 underscore diff col, nothing but different columns, just to make the table names different. And the structure is different for both the tables. Okay. Now we are going to see two things in this activity. There are two different things we are seeing. One is the column name mapping, and also we are changing the column order. Okay, just to increase the complexity. I don't want that the column order should be same as it is on the source. So we have changed the column order also, and we'll be looking at mapping of the columns where the column names are not same. That means our structure is completely different. So below is the mapping order of our tables. Now what is the mapping order? See, in the tab 3 on the source, I'm using this column names 1, 2, 3, 4. On the target, I'm using column 1, column 2, column 3, column 4. But on the target table, what we have done is the order of the table is a little bit different. So the 2 will be mapped to the column 3, nothing but this one, column 2. That means it's the third order in the table, and the 3 will be mapped onto the second column, in terms of order. See, if you go with the numbers, that means it will be 1, 2, 3, 4, but we have changed the order, the way we are going to create the table. In this case, column 3 will be mapped to this 3, and column 2 will be mapped to col 2. Okay, so we have a different order over here, and we have a complete set of different column names, right? So let us look at how are we creating the table. Once you look at the tables, then you'll understand. If you look at the tables, just to increase again a little bit of complexity, see, 1 is defined as number, and on the target we have column 1, which is again defined as number. So 1 will be mapped to column 1. Perfect. Then we have 2. As per our table, 2 is to be mapped to column 3, right? You can see 2 is defined as varchar 2. And in this case, what we have done is we have defined column 3 as varchar 2. Okay, because we have to map 2 to column 3. And then what we are doing is we are mapping 3, which is of number, to column 2, which is again defined as number. And then 4 is mapped to column 4. So 1 and 4 are direct mapping, even though the column names are different. That means, guys, remember, this is not a semi-different table. The example of a semi-different table would be, I'm just giving you an example. On the source, you have 1, 2, 3, 4. Okay. And then on the target, you have 1, 2, column 3, and column 4. This is a semi-different table. Okay. Where the column names are exactly same. But over here, we have mapping directly, but the column names are totally different. For 1, the mapping is column 1. For 4, the mapping is column 4. So these are straightforward mappings. But 2 and 3 are mapped in a different order, right? So this is what we are going to create. Let us create these tables. I think first we have to start the VMs. These are very nice activities. I mean, going forward, we'll have pretty good activities. Prod, and then we have dev. So going forward, we'll be creating the source definitions file. I'll update you. There is a new Golden Gate utility we are going to use that is known as defgen utility. That will generate the source definition file for us. And once we are done with it, then it will be a normal setup. Rest all remains same, except the column order and column names are completely different in this activity. 192.168.0.181. This was gg prod local, and then 182. Let's see if the VMs are up. Great. So I changed the color. We'll switch to Oracle user. And let me connect to the second machine. Switch to Oracle user. Okay, first of all, we'll have to start the database. Let us close this one, not needed. So in the source we'll be creating with the Fox user. On target we'll use the same Tom user for this activity. Next we'll be adding the supplemental logging for this table fox.tab3. Okay, so this DB is up. Oh, first we have to create the tables, right? Let us create the table. So let me connect to Fox user. And on target, okay, it's yet to come up. So let us create this tab 3 on the source. Okay. And then, good. On target, we'll connect to Tom. And then we'll create this table, tab 3 underscore diff call. Nothing but it is regarding the different columns. Looks good. Next, we need to add the supplemental logging for this table. So we'll log into the database with ggsci. My machine seems to be pretty slow today. TB login, user ID. Okay. Now, info run data fox.star. So we can clearly see that for tab 3, definitely supplemental logging is not added. Add run data fox.tab3. Okay, so once the supplemental data has been added, now what we are going to do is we are using a defgen utility. Okay, let me try to explain you this one. See, in the GG home, we have a utility that is known as defgen. This utility will use to create. That means we'll have to feed few things to this utility. What is the heart of Golden Gate? Parameter files. That means we have to create. What's the first step? We have to create parameter file for this defgen utility. Now this parameter file, definitely when we are creating, there are always two ways. What is the first way? You can use VI editor, and the second one is you can use ggSCI prompt, correct? We'll be going with ggSCI prompt because it's easy. Now also all the parameter files are by default stored where? dir prm. First we'll use ggSCI to create a parameter file for our defgen utility. Now what is contained in this parameter file? This parameter file again contains few details about your table for which you want to generate the definition, and then output. That means where do you want to keep the output definition file? So the output definition files generally go in dir def. This is a default folder. So in this dir def, all your definition files will be there. So we'll feed two things, nothing but we'll feed the parameter file to this defgen utility. It's a separate utility. I mean, you need to run it through Golden Gate home, not inside the ggSCI prompt. Okay, it's a separate utility. So we'll run this utility, we'll feed the parameter file. The parameter file will contain the details about the table for which it should store the structure or it should capture the structure, and then we'll also define where do we want to store the output definition files, or where do we want to keep the definition file output. Now once we get the definition file, okay, example, our definition file name is output.def. Just an example. What we need to do is we need to copy this from the source server onto the target. On target, where you will copy? Again, gg home dir def. We have to copy this definition files onto the target server, Golden Gate home and dir def location. And then next, when you run the replicat on target, when you are running replicat, the replicat parameter file will have a pointer to this definition file, because going forward we are not using the assume target defs, right? This parameter we are not using. So that means we need to define, or we need to give the definitions file inside the replicat parameter file. So this is the whole process what we are going to do. Now we are going to learn about a new utility that is known as defgen. Let us start. I have given some details about this utility. As our source and target database have different structure, we need to create a source table definitions file and copy it onto the target server. We use a defgen utility to create definitions file. This utility comes with Golden Gate binaries. First, we need to create a parameter file for the defgen utility. So without any parameter file, no utility will work in Golden Gate. You can create it via Golden Gate prompt or manually via the VI editor. But I will always choose the Golden Gate prompt. Okay. Now, how do we create a parameter file? We can simply give edit params, and you need to give the name. Just give any name. Okay, you can give any name over there. So with that name, the parameter file will be created. See, for example, edit param ext1. So what happens? It creates a parameter file with the name ext1.prm, correct? Now over here also I want to create a parameter file. So I'm just giving edit param and I'm giving any name. So we are using defgen1. That is nothing but we are generating our first definitions file, right? Now in the next activity that we have over there, we'll be using defgen2 because that will be for the second iteration or the next table, right? So let me copy this data for you and we'll talk about it. As I mentioned, we have to give two important details inside the parameter file. First of all, where is your output definitions file? Where do you want to keep the definition file? All the definition files, nothing but the output that will be generated. It is not generated. This output file will be generated in the Golden Gate home. Can you see? This is the Golden Gate home, and then dir definition location. Then you can give any name to your definition files like fox tab 3 def. That's nothing but fox table 3 and then definition file .def. So .def is the extension that we should use. Next, we need to provide the login ID password of the admin to the database, and then table details. Whatever table you want to get the definition over there, then you need to put that table details. So let us create this definition file. Okay, edit param def gen1. Just we are giving some name to this definitions parameter file, and we'll copy this one. So my def file would be under Golden Gate home dir def fox tab 3 definition. Let us save this one. Now what happens when you do this one? Just to show you guys, I can get inside dir prm directory ls-lrt. Now can you see a parameter file is created defgen1.prm. So simply if you want to create any parameter file, you can just give edit param, give a name, and a parameter file will be created in this location. So we are not using the VI editor. Let's continue. Now because this defgen utility is, it resides under your Golden Gate home, ls-lrt defgen. You can see this defgen utility, it resides under your Golden Gate home. We have to use this defgen utility, and then we have to feed the parameter file. Parameter file will be the input for this defgen utility. You can see /defgen. We are running this defgen utility, then param file, and then the parameter file location. So the parameter file that we generated above, the parameter file name is defgen1.prm. We have to give the full name, and it resides under dir prm. So once you feed this one, then this will read the parameter file and generate the output definitions file. So we'll see how it generates. Okay, so see .defgen and the param file. This is the location of the parameter file. So let us hit enter. You can see now Golden Gate tried to create the defgen utility tried to create the definition file, and we can also see that definitions file generated for one table in this location. Nothing but the location that you provide inside the parameter file, the same location our definition file is generated. Let me go to this location dir def ls-lrt. We can see our definition file is generated. Let me cat this file. Okay, so over here you have some details which are actually understood only by Golden Gate, because you need to understand few things, that Golden Gate is a hybrid product. It is used for replication for multi-vendor databases, right? Now in this case, this is only understood by Golden Gate as to how they output the columns and all those numbers, how it integrates it for the mapping purpose, right? So just to show you guys, I just opened this file. It's okay, you can cat it. It's a normal file, not a binary file. Next, so what we have done, we created a parameter file for the defgen utility, and then we ran the defgen utility to create a definitions file. Next, we need to copy this definition files onto the target server, again under the same location. Now remember, this Golden Gate home is onto your target server Golden Gate home. Assume on target, if your Golden Gate home is in a different location, you have to put it over there. Okay, don't put it in the or don't try to create your directory structure as the source server. That will not work. But in our case, if you see, our source and target structures are same. I mean the installation structure, I'm talking the directory structure. So I can just simply do an SCP of this one, oracle@ggdev, and then I'll use Golden Gate home /dir def. Okay, great. So it is copied onto the target. Just to make sure, I'll check on the target. Of course, it would be there. dir def. Okay, it's there. Now this is the only extra step that we have done. The rest all remains same. The rest we'll have to start with the extract process. So just to quickly add up these processes, what I'll do is I'll just run through the document. Now see, on the source, what we need to do. So let me get inside SCI TV login. So info all. Oh, we have good number of processes. Let me start the MGR, and let me start the MGR on target as well. Start MGR. So it should be running. Okay, manager is running. So info all, on target also it's running. Make sure manager is up and running before you start off all these activities. So we are trying to add a new extract. So when we add the extract, this is the new naming convention I'm using over here. For your understanding, I have put up this line: extract naming convention. P as in prod, Fox is the schema name, T3 table first and last letter, E as in extract. Okay, like for the data pump, I'll be using D at the end. So don't worry about the naming convention, you can use anything that you want. So, but yes, we have a topic where we'll be discussing the naming convention standards that you must follow in real time. I mean, you can give any name, but it is always good to have a standard. So add extract pfox t3 extract e integrated. We want an integrated extract, and we want it to use right away. So begin now. We have to register the extract with the database. This is important. And next, we have to define the source trail where this extract will be writing the extracted transactions. Okay, extract is successfully added. So add exe trail. I'm using the trail names as T3. Okay, that's our table 3, right? Tab 3. So I'm just using that naming convention, and I'm attaching it to pfox T3e. Nothing but our extract process. So for our extract, we have defined the source, we have registered it with the source, we have defined the output of the extract process trail file. Now we have to define the parameter file. So we'll edit the parameter file. The parameter file still remains same, no changes to the extract. See, extract the process name, next is your admin login, then your output file name, and finally we have the table name from where we'll be extracting the data. So it is fox.tab3 in our case. So our extract has no changes. Perfect. In the data pump, again, we will have no changes in the data pump also. The only change in this case would be in the replicate. Now add extract. We are adding another extract. because pump is also a secondary extract, pfox t3, and then at the end I have d. D means data pump. So I'm using this naming convention, and then I'm defining the source. So from where this data pump process will read. If you look at the trail file, this is nothing but the same trail file that my extract is writing to. So the extract output will become input for the pump process, right? And then I have to define the remote trail, the output of the data pump process on the remote server where I want to write the remote trail files. For remote trail files, I'm using R3 and I'm attaching it to pfox t3d. Nothing but the pump process I'm attaching it. Guys, don't worry, I've just used a little bit complex names for our extract data pump because I want you guys to be used to the real world naming convention. Nothing has changed. I mean, you can use again dp1 or ext1 in order to understand in case if it is confusing. Next, we have to add the parameter file for this pump process, edit param, and the data pump process, we have to edit the parameter file. Again, the parameter file is pretty simple over here. Process name, admin login, and then in the data pump we have to give the remote host details, manager port, remote trail file. Okay, this is R3, and then the table details for which it will be pushing data onto the target server. Perfect. So two things are defined. Now create golden gate replicate on target with mapping details of our columns. Something new you will learn over here. So before I start, let us discuss about the replicate parameter file. So what is the new thing you guys are seeing in this parameter file? Anyone? New parameter?
Call map.
Yeah, correct. Over here you might say, oh, it's so simple. Yes, it is very simple, but we need to understand few things over here. What are they? First of all, we are not using the assume target defs over here, correct? That parameter is gone from our replicate file. Next, we are using a new parameter called as call map. This call map parameter is used when you have to define the mapping. Okay, so next we are using call map parameter to map target to source columns. Now you might say, why did I write target to source columns? It is not source to target, it is target to source. Why? Let me open the document. Now if you look at this table, we are mapping from target to source. Column 1 is being mapped to 1. Can you see? So first you need to write the target column name, and then you need to map it onto the source. Again, you need to write the target column name, you need to map it onto the source column. Target column, source column, and that's why I write it call map parameter to map target to source columns. Okay. Also in this parameter, if you see, we have done our mapping perfectly. One is mapped to column 1, you can see. So column 1 is equal to 1. Then we have column 3. Column 3 is mapped to 2. You can see column 3 is mapped to 2, right? And then our column 2 is mapped to 3. In this case, this is the mapping we have. Next we have column 4 equal to 4. That's the direct mapping, right? So with this parameter, you have to define the target to source mapping, not source to target. Next, one more observation that nobody told me. So nothing but it is our source defs. Location of your source table definition file. So these are the three major observations in the replicate file. Assume target definitions is gone because our table definitions are different. Column map parameter is added because we want to map the columns, and this parameter will help us map target to source, not source to target. Rest all remains same. Can you see map fox.tab3 and then target tom.tab3 underscore column, sorry, diff call. If you look at the normal replicate file, it would have been like this, correct? Remember, you will have a semicolon after all the table details, you have to put a semicolon. You don't put a semicolon for any of the Golden Gate parameters or Golden Gate defined values. But for the table mapping, you have to use a semicolon. But in this case, column map continues with the same, map statement. And in this case, you can define the mapping of the columns. So why it is defined like this? Because let us assume you have other tables. So in that case also you can define their all, the respective table column mappings in the new lines like this. Might happen, right? So we don't have multiple tables right now. We'll not have them. So let us create the replicate for our replication, right? So let us log into the target DB. Now we are already in. So add replicate. Over here again the naming convention, if you see, D as in development server. Okay, earlier it was P, right? Prod server. So this is D, development server. Then the schema name, that is Tom. You can see next is schema name Tom. And then I'm using the first and last letter of the table, that is T and L. If you look at the target table name, it is T, the first letter, and last is L. Just my naming convention way. You can have any naming convention that you want. Okay, and then I have to define the ext trail, nothing but the source for this replicate. The source will be our data pump output file, nothing but R3. If you look at the remote trail file, the trail file name is R3, right? So R3 will become source for this replicate process. So let me add this replicate on the target. So info all, where is our replicate? This one, right? So this is our replicate. Next we need to edit the parameters for this replicate, and we'll put these parameters: replicate, user ID, password, then source definitions file. This is the definition file. Next is map statement. Okay, great. Now let us save this one. Now one thing I would request you guys, before you start this kind of replication where there is a linking to file, just do view param, this one, right? And then exit. Just do an ls-lrt, check whether your source definition file reference is correct or not. We can see that it is in the proper location, because just in case it will save time for you, there might be location error, might happen, right? So let us get inside the ggsi db login user ID. Okay, so source defs, this is like specifies the source definition file location on target server, and then column map specifies the non-default mapping of columns from source to target, right? Now simply what we can do is we can start the extract, pump, and replicate processes, and then we'll try to insert some data onto the source just to see whether mapping is working perfectly fine or not. So info all, we have so many processes. Okay, so let us start pfox. No, pfox t3e. This is the naming convention I'm using. Okay, and then I'll start the pump process. This is started on the target. Let me start the dtom tlr. Okay, these names are crazy. Info all. Right, so we can see these two processes are up and running. Great. On the target, let us check whether replicate is running or not. We can see replicate dtom, this is running, right? TLR. So just in case, you can try to check it for some time, because you know what happens, it takes little time for process to get abandoned or in the abandoned state. So what you do is always when you start a process, don't immediately get out of the ggsi, wait for some time, just a minute or two, see whether things are still running fine. If they are running fine, then proceed with your activity. Okay, so all the processes are up and running. We'll exit. SQL Plus will connect directly to Fox. So select star from tab. So this is the tab 3, right? Select star from tab 3. We have nothing in the table. Let us insert some rows in this table and then we'll commit the transaction also. So that's tab 3, right? Okay. So select star from tab 3. Okay. Now, if you look at the mapping table, what we can expect on the target. On the target, the column 3 on the source must be listed second, and then column 2 on the source must be listed as the third column. So these two columns are to be swiped onto the target. That means third column data you will see in the second place on the target, and the second column data you will see on the third place on target. So before going on to the target, let us examine the reports. Okay, we can see that extract is running, pump is running. So stats, we'll check the stats for the extract process first. We can see that it has captured total number of inserts. 3 inserts have been captured. Perfect. So inserts are captured by the extract, and let us look at the stats for the pump process. We can see that again pump has sent or processed the 3 insert statements. That means these insert statements have been pushed onto the remote trail file. Perfect. Let us go to the target server and do an info all just to see whether your process is still running or not. Our process is running. So let us do or check the stats for this process. Now can you see total inserts? Even this process has performed 3 inserts. That means if we get inside the database, we must see the data. So let us connect to the target database tom/tom. Select star from tab. So what is the table name? Tab 3 underscore diff call, right? Select star from this one. Okay, now can you see our column mappings are working perfectly fine. So on the source, where is the table? Yeah, let me push it a little bit over here. Now can you see the column 2, the alpha, beta, gamma is reflecting in the third place over here, because that is how we have defined the mapping. And also the column 2 is having 10, 20, 30. That is the data of the third column from the source table. Right? So that means in this activity what we have achieved, we have achieved, okay, not achieved, what we have learned like how to perform the mappings of tables when the table column names are completely different, and what if we want to have a different order. So guys, any doubts, anything you have, any observations, anything? So if all good, I'll proceed. And not just a column that are actually different. Okay. Yeah, Nikhil. So in the next activity, you will understand. Okay. So also, can we use source defs when table structure is same? Okay, I don't know if you gone through yesterday's video or not. Can you see source defs was used in 11G? Okay, so from 12C onwards, it is no assume target defs. Now in this case, we are not using any of them because none of them is default. So you will understand when we use no assume target defs. Okay, in your project, I'll let you know where exactly. So also, can we use source def where table structure is same? No, that you can use only in 11G, not in 12C. So if you're using 11G and your structures are same, then you have to use 11G, not the database. I'm talking about the Golden Gate version.